Hey, everybody. All right. Make sure my volume's not too high. How's everybody doing? Let's get some music started. Make sure it's a reasonable level. Checking levels. All right. Nothing too loud. Didn't start chat. All right, so I missed you guys last week. Had some life stuff come up again, and thinking now there'll be another one next week, maybe. Well, maybe. We'll see. Hey, there's a bunch of chat in here. Everybody's been going crazy, huh?
Frankly, my dear, I don't give a damn.
Cthulhu Lover says, I hope the stream won't be rescheduled as the last moment. Been looking forward for 2 weeks now. Yeah, sorry. Yeah, the last minute thing was unexpected. It was just something I had to deal with. You know, life throws stuff at you. Let's see, catching up on stream. We're still working on trying to finalize some Vulkan and DX12 stuff. I did some of the work over this last week on the performance optimizations. It really wasn't a performance optimization. I'll get into that here in a second. It was actually like a problem in the Vulkan API. But I'm going to take that and take that towards the DX12 stuff as well here in a second. So let's get started. So yeah, last time we were working on just getting it up and running with Vulkan and DX12, and we got that. And then I've been just basically trying to finalize Vulkan and DX12 enough that we can ship it. So that's the plan for today, is to keep working on that. So let's just start. No reason to chit chat anymore about it. All right. There we go. All right. So let's start at the beginning. So the performance problem that we had was related to our Vulkan code. I don't have kind of a before and after to show you, but where the heck is it? There. It was basically, it took me a while to kind of diagnose it. What I was noticing was that first I noticed is the frame time was really bad. No matter if I was, no matter where I was looking, it seemed like the frame time was really bad. On Vulkan in particular, when I compared it to DX11 to Vulkan, it was like significantly worse. I was like, even when you're not looking at things, it's still really bad. So it's like, well, there's some bottleneck somewhere. So I started measuring, and in the process, reworked my code for measuring time for the frame, which actually I didn't need to do, but I was thinking like it must be the timer, it must be wrong somehow, right? Always thinking it's the code can't be the thing, it's got to be something else. Eventually rewrote all that and found that, the update call was taking very little time, but the draw call was taking a ton of time. At first the update call and the draw were taking the draw was taking a lot of time. So the first thing I noticed was that part of the design of what we had here, we have kind of this begin frame call that we put in at this is called from C#. Say, hey, we're getting ready to draw some stuff. Now, this is probably a bad idea. We probably shouldn't have this. And this is just we need a begin and an end, How does that, you need some way to say we're starting, and here's a way to say we're ending. But the truth is, you really don't need that. You just need to know that, and that's not how XNA works. XNA doesn't have a begin and an end. It's like, once you initialize the graphics device, it's ready to render. You call present when you're done, and then it's ready to render again. So one thing that we did was we removed all the work from begin frame at the native level, and maybe one day we will depreciate this function completely. But the idea was that it was like in here, it would be blocking for the next frame, meaning that every time the first graphics operation would take a long time potentially, while I was trying to wait for the back buffer to be ready to be able to render to, right? Because the in-flight data is there. So if you're GPU bound, it would get to begin frame and it would wait until it could actually start rendering. The problem with that is that you'd see, like, what we expected to see was in the update call, it's just CPU performance, no GPU there at all. On the draw call, at the end of the draw call, when it calls the base and actually calls present, when it actually calls present, that's where all the waiting time should be there. Instead, what was happening is the first draw that you did, be it a clear or a draw or whatever, first graphics operation you did would end up calling begin frame, and then it would block for a while waiting for the GPU to be ready. So that was kind of a bad design implementation. It means that performance-wise, it worked differently than XNA did, and kind of is outside the expectations of, and also like DX11, it's just outside the expectations of what you wanted, because everybody expects it to be, you expect the present to be the thing that takes a long time, not a clear at the beginning of the frame. So getting this work out of here, which is something I need to do on the DX12 implementation as well. I need to go look at that. But I think it's actually okay, but I need to double check it. But getting that stuff out of here was important. So where the work actually went is down here into present. So present now in this code has been reworked a bunch. Ends the command buffer. It grabs a queue lock, which that's kind of important. I'll talk about it later. Sets up the signals, submits it, calls present. And then after that, so present here does the present. And then after present, like these things don't take any time. It's just queuing them. And then when it gets down here, it calls prepare frame again. So this is where the code that used to be in the beginning of the previous frame, or at the begin frame, is now happening here. Cthulhu Lover says, how did you profile it to figure this out? Which tool did you use, or did you use one? I didn't really use a tool because the profiler doesn't do a good job of keeping track of this, really. I had problems using the profiler, or at least I haven't really used a standalone profiler in a very long time. I've gotten lazy and just used Microsoft's built-in profiler in Visual Studio. So I was kind of doing that, but the results it was giving me didn't make sense. So what I ended up doing was I ended up just putting my own timers in to kind of figure out where things were happening, and that led me down this rabbit hole where I finally figured out that it seems like basically what I did there is I figured out the draw was taking up all the time, and it had nothing to do with the present. Present was always fast, so it was like it's not blocking for the frame there. That's what led me to like, well, where is it blocking? And then I realized the first thing when I draw blocks, because that was where all the data was, or all the work was. So this stuff in here in this prepare frame, this is the stuff that would be blocking. Acquiring the swap chain. This is actually the work that does the blocking. It's frame, is it rendering? Wait for the fences to finish, so we know that we can reuse the current frame data, which is basically the command buffer and stuff like that. And again, when it's blocking here, it means there's already another frame in flight. So it's like you're trying to reuse frame 0 while frame 1 is rendering. You're trying to use frame 1 while frame 0 is rendering. And then it basically at that point, it gets the next swap chain image and then resets the fences and it's ready to draw for this frame. So that was happening at the beginning of the frame. Now it happens at the end of present. So it goes from I'm ready. It basically is always in a state ready to render, which that happens. Like if you think about even DirectX, you can put draw calls in your update function. There's no reason you can't. You can also clears in there. You could call. Things like setting data on a texture. Even those things are at times implemented as GPU operations. So things like that have to be able to draw at any point. So that's why it basically needs to be always in a state of ready to render. So this moves all this work here, and it took a little while to kind of clean it up and get it to work properly, because there's a lot of little subtleties to how this thing synchronizes. I've been using RenderDoc to capture frames for the new dynamic font stuff and see how it's batching uploads and VMAT for profiling stuff. Yeah, I've used RenderDoc in the past, and did I try RenderDoc on this? I think I might have tried RenderDoc on this, and I was like expecting to see it must be this, there's bad performance, so that must be the issue. And when I looked at it, all the rendering seemed to make sense. And RenderDoc really won't tell you that you're blocking in the wrong place. So I expected, it wasn't that the performance was bad, it was that the performance is in the wrong place. I thought, why is this so slow here? It doesn't make sense. And then, so that was the first thing, was the performance is the wrong place. Then we got actually to the thing that well, why is this slower than DX11? That's the next problem. So the next problem was, texture set data. That was the actual problem. So the problem with texture set data was that it was basically flushing, whenever we would call set data on a texture, it was basically flushing the command buffer in progress, drawing something, because it has to do kind of it uses the GPU to do a copy of a staging buffer to the actual texture. So create a staging buffer, which that happens in parallel, and it maps the memory, copies it on the CPU, unmaps the memory. Then it says, okay, now let me get a command buffer and tell it to make a copy of this buffer into this texture, and then submit that command buffer. And that was all happening, it was happening, and it wasn't happening in parallel. It was basically stopping whatever was rendering and doing that. So basically every time a texture was being updated, it would do this. Well, you wouldn't notice this in some games, but in this game you did, because this game was updating two different textures in the middle of a frame, every frame. Ascent basically is uploading the texture and the light information, which is it's a 2D image with light data in it, and it's updating another texture that has I guess it's the cluster data is the other image that it's updating. So it's updating these two textures, and every time it would do that, it would block the frame, and that would happen in the middle of the draw. So the draw was taking forever, and I couldn't understand why. And it was because every time it called set data, it was doing this crappy blocky work. So that said, now it doesn't do that. So I reworked this a couple different ways. You can see like some of the path that I took at first. At first, I was trying to make it fully threaded, where every thread that tries to, because I was thinking about threaded loading at some point. So it was like, well, if I create a thread static that has all the data for being able to handle this, these transfers of data from the CPU to the GPU, then it would be fully unsynchronized to the main thread, and it can work on its own. It won't interfere with the main thread. I was working on that. I couldn't get it to work exactly right. There was issues with cleanup and stuff, and it was like, this might be overkill for what we need, especially at the moment, because I needed to get things done. So I've kind of backed off on this design, and now I've gone to a much simpler design, which is very easy. We block on the queue, we get the command buffer from the main device. So it's basically using the same device's command buffers. It doesn't use a different command buffer. It uses the same one for the main device. Grabs a command buffer, fills it with data, and calls submit on it while it holds the queue. So a background thread will interfere with the main thread, but only when the main thread is trying to do submit will it be blocked by these. And it holds it for a second just to do the submission and then goes away. So it's fairly, it's not very invasive to everything. But yeah, this is a simpler design than what I was trying to do it before, and it works. And we can evolve this and make it better later, but I think this is a good starting point at least. If we get to the point where we see some really high-end stuff saying like, we're starting to see these locks happening on the main thread that are coming from these background threads, then we can kind of address it. I mean, there are already locks here, like in fact, that's one of the optimizations you can kind of do. Like whenever we go to allocate this buffer, we have to call VMA create buffer, which is it's the memory allocator for Vulkan. And internally, this is already by default initialized as being thread safe. So you can call this for any thread. Internally, it basically calls a lock and allocates the data and returns it. So it's locking internal to here. So one thing that is an optimization people talk about is that you disable the locking here, and you put your locking at a higher level, so that if you know you're going to lock and do a bunch of stuff, allocating buffers, you don't lock, unlock, lock, unlock, lock, unlock. You lock once, create all your buffers, unlock. So handling it yourself. But I decided for now, we don't want to go that crazy. Let's keep it simple, make sure that it works. Once we're stable and it works, we can then start working on, hey, can we make the internals a little bit faster? So with this in place, we now have, and I'll run it real quick. Actually, that's the wrong thing. Wrong thing. Where is it? There we go. So yeah, so now when I start this thing up, I fixed a bunch of different issues with resizing, issues with, there was just so many weird issues going on at the time. So now, when we're here, you can see update, the frame time is 16 milliseconds when the VSync is on. It is, ridiculous fast when the VSync is off. Update time is separated. I separated these two so I can get a better idea of what was happening, because it was kind of confusing just to see it frame time versus CPU time, because CPU time was including the present wait, which is what I didn't expect. So you can see what it's actually doing here now. If I go to the game, it takes a second here, and this is something I want to take a look at here, is why this is taking so long. Because it takes significantly longer than DX11. So now we're running at basically the same frame time as it is on DX11. It's a little slower, but not that much slower. I also had to disable disable a validation when I'm testing this, because validation really slows things down. That's a bug there. And that light turns off there. That's one of the bugs that I'm noticing here. It's only happening here. It's not happening in DX12. So there's something going on with that. I'll have to look into that. Maybe we'll get to it this stream. So yeah, so with VSync on, you see we're hitting 60, and frame time, which is the overall time of the frame, which includes the present, is 16 milliseconds. The update time is just, it's half a millisecond basically. And then the draw time is around 6 to 5 milliseconds. And then if I take the VSync off, you'll see that, update time is the, you can see that nothing there changes. Those times stay the same. It's just the frame time that changes when VSync is off. So it gets up into 70 frames per second in that mode, which is a little slower than DX11 is at the moment. I mean, there's more optimizations to do, obviously, but it at least gives us a good idea. And we can now see the actual FPS getting higher when we look off screen, when it doesn't have to draw as much, and then it slows down once it's starting to draw more pixels. So it's doing the right things now. Before it was not. It was clearly not working properly, and that was a big problem. There's also crashes on some resizes. Toggling VSync caused it to crash. There's a bunch of things here that were broken that are fixed in this update. So what I was doing this morning, or for a little while here, let's see any posts. Yeah, I was mostly yeah, upload safe to upload from background threads. Yeah, that's the thing that I wanted to be sure was working. We have some other projects that are being blocked on some issues with DX12 and having it properly handle threading, which we've gotten a hack version of, and I have a PR up for that. But it's not working very well. There's still some issues there, and I want to kind of unify this and make it work. So when I was working on Ascent and saw these Vulkan issues, I addressed that first, and then it's like, well, part of this, let's fix the threading issues and make sure that we're safe there. So one of the things I was just doing was I set up a unit test. Set up a unit test for threading, which we haven't had one before. And I'm starting simple. Like, here's one that just creates a texture, sets it, and gets the data in the background thread. While it's while the main thread waits. So it's just making sure that we can operate on the thread in the background thread correctly. Now, I know that some platforms we might have trouble with it. But with Vulkan, DX11, DX12, it all should work. There shouldn't be any issues there. It's just GL that might have issues, and we'll deal with that later. So the first problem I ran into, and this is the first time I've run the unit test here in a little while, after I updated, is it wasn't finding my DLL, which is that same old freaking problem, which I fixed previously, but I think when I updated to the latest stuff that people had merged, it might have broken it, I think. So I need to figure out what's going on there. So let's get back to that real quick. So this should be executing. Okay, so that looks, does that look correct to what this thing is trying to do? Oh gosh, that's not what I was trying to do. So artifacts, native. Okay, well, there's where a problem is. These things are flip-flopped. Wait, is that true? No, it's right. No, that's right. Okay. I got confused there for a second. MG runtime, desktop VK, Windows, native platform. I think that's the problem, is that this is not outputting to this native platform is this Arch thing. I bet you it's not. I don't want to mess with this right now. I think I did this last time. I just did that. It's dumb, but it works. Like, I just don't want to spend the next half hour trying to figure this stupid thing out. I just want to move forward with what I was trying to do, which is test this. Yeah, I still didn't find it. Annoying. Why is it failing? Let's make sure it actually. It's really, what really annoys me is that I had all this working before, and after I pulled, things broke. Let me do this. I'm going to rebuild. I'm going to have to just look carefully in here, see if I can see this operation happening. So much garbage I don't care about. Oh, God damn it. Our music got lost. Never once remember to loop that music. Yeah, I mean, it should be building the right thing. I just hate it when somebody moves my cheese. Yeah, that stuff's all right. Okay. Creating library. Okay, so this should be where it's at. Just make sure, huh? Okay, so I'm going to delete this guy and build. Should rebuild it. Yep, put it back. So it's in the right place. Sure my dependencies are right. Yes. I think it just didn't execute that. God damn it. Let me just look in the output folder real quick. All this dumb plumbing test. Okay, debug. Yeah, I think this is the right thing, but let's be sure. It is the right thing, and it clearly did not copy it to here. So what broke here? Because this was working previously. My guess is that it's this shenanigans up here did it. That's my guess. There was a PR upstream that's like, oh, let's change this because it's wrong and it doesn't work right. It's like, okay. And now it's broken. How do I do that? Let's see. I need to put some logging in here. I forget how that works. Let's see what Claude thinks. I always forget how it works. Message task, that's right. And I can embed strings in it. Good. Importance high is important. Can I put it here? No, I can't put it in there. I got to put it in a task. That's the annoying part. Okay. Or target. So I got to put it into. Damn, I hate doing this, but I'm not gonna be able to log it like that. I'm gonna have to just do the horrible thing. Just come into here and where is it? Logging in diagnostics. No, wrong one though. Wait. It's not in there. Where is it? And yeah, I noticed that I didn't remove that. I put it back. It didn't change anything. I'll do it again just to be safe, but it didn't do shit. Yeah, it didn't do shit. What was I doing? Oh yeah, I was. Where is that? I forget where that is. Projects and solutions, build and run. That's where it is. I have to tell MS Build to diagnostic, and when I build this, it's going to spit out. Well, thought it would. Did I hit the wrong one? Maybe I hit the wrong one. Build log verbosity. Build output verbosity. Okay. Huh? It's like it's not seeing this because this is what it should be calling, and I should see something more than I'm seeing. I just do a rebuild, I guess. Make it worse. Actually, I know what to do next. I'm going to try something different after this. This is why I hate turning this thing on, is it's this mess. But at least then I can try to find some of these things that it should have called. I should be able to find that. See, it's like it's not seeing that at all. That should be in this list somewhere. Why is this so difficult? Don't understand why this has to be so difficult. I'm going to rebuild just this, just to reduce some of my... why can't I just rebuild this one project? What happened to that option? artifact that's not even in here. It's like it didn't include this at all. Why is none of this in there? Is this an SDK thing? What if I do the, what is it? It's not that. What is it? Of course, I don't have it on any of those. Forgot the flag. There's a flag that tells it, hey, don't do the fast build thing. The build log, it logs everything. Like it'll log every property. It should be in there. Native platform should be in here as well, and it's not. Why is none of that in here? It does log. It does log that stuff. It has to because this is the verbose output. Yeah, that Sablefast update check. That's right. I'm going to put that in here real quick because that seems to always be the magic sauce that makes it function. Hey, look at that. It probably added it. Nope. I saw some movement. I thought it would have added it. But hey, it at least might have done everything now. I could swear this is supposed to be in here. Okay, I'm just going to look for every reference to MG Runtime DLL in here. It's not in here at all. God damn it. Is it this thing? Ray Noisy. Hi, Grandpa. Hello. How's your grandma? Let's see. I am extremely frustrated. Okay. I fucking give up. I give up. I give up. I'm not going to spend time fixing this again after I had it working previously. In fact, you know what I'm going to do? I know what I'm going to do. I'm going to revert the change locally because fuck that shit. No, I want to roll back to this, I think is what I want to do. What's the right way to do this? I think keep changes doesn't break everything. Yeah, that couldn't. It's just rolling it back on this one file. At least I think that's what it's doing. Hate it. It just changes those two files anyway, so it's not doing a big deal. And actually, let me see what actually changed, because that might have something to do with it. Visual Studio, can you give me a smaller window to look at stuff in? I wonder if that has anything to do with it. Yeah, I'm just going to do this. If that doesn't fix it, then it means that something else is broken. copy. Yeah, let's copy these two property groups. Hey, look, MG runtime's in here now. So whatever was done there, like, just broke everything. It's just so frustrating. And it's still not in there. That's so weird. Like, the whole purpose of having the verbose logging is so you can see exactly what it did, but it just doesn't show you that part. You can't tell what it actually did anything. That's so annoying. Anyways, it should be in there now. And look, it's in there now. All right, so I can go back to what I was wanting to do, which is to run a stupid unit test. Hey, look, it ran a unit test and it succeeded. So that's good. The next thing I want to do here is I want to make sure that it works even if the main thread is rendering, which my current test is not doing that. I'm so glad I just reverted that local change. You know, I don't care what anybody does upstream. If somebody wants to create this thing to do something weird upstream, that's cool, whatever, but I just need it to work here. And if I had more time, I'd try to fix it locally. I just know now how to fix it, which is to throw it away and start over. All right, so we have this test. I think I can use the fixture test to render, I think. Yeah, I mean, I think I can render with a fixture test, right? Yeah. Yeah, as long as I have a fixture test, I can render. So what I want to do is I want to basically sit here and clear until this thing is done. Yeah. So let's do like, well, the problem is this isn't enough, right? This is a simple test. I need a test that's going to do a bunch of work, not just one, because that's not enough, I think. Yeah, let's duplicate this test, and let's do something a little bit more elaborate. How about what background voting? I'm going to give it a list of textures, which I am pretty sure I have a bunch of textures in here I can use as a test. Where are those tests at? These are the non-visual tests, actually. Yeah. And FromStream should work for this test because it's just going to load and set data in it. Yeah, it's possibly because of a local setup issue, but, you know, I can't tell you what it is. I just don't want to dick around with it any longer today. It's just a waste of time. So yeah, I'm going to take these guys and I'm going to use them for my other tests here. Let me throw this into a list. An array works too, huh? Actually, what's a fancy way to do this? Do it this way. Always forget that I can do fancy text editing. Have it sleep a little bit before, well, no, it shouldn't need to sleep anything. And I do want to put it inside a try catch because I don't want it to fail. I want it to load all the textures, so let's put a what is it not like here? Weird was highlighting it but saying like I don't know what this is. Sure. What was this thing doing? From stream. And from file, I think works the same way, doesn't it? Where does from file come from? Is that part of the framework? Okay. Because it's all relative to the content folder, the game folder, I guess, or where it's running from, so it should be fine. Needs graphics device. I think this is just going to load all this stuff super fast. MonoGame Orange. It is alive. I think that's it. Yeah, I think it's correct. Keep it simple for right now. And I need to come up with some checks here. We'll worry about that after we get this a test real quick. Just want to see if this actually functions at all. And then we can worry about improving it. Turn off that verbose logging. Okay, it ran, didn't blow up, so that's good. Took a second, but I don't know if that's actually true, if it was just compiling. Okay. I want to just see that it actually loops more than once. I guess I should probably count frames to verify that it. Oh. Okay, did it. All right, so it is doing it. So it is rendering while it's doing that. So that's what I wanted to be sure of, just to be sure. I mean, I'm pretty sure it's doing it, but I guess I could count or something like that. Let's see that. just in case. Assert true frames greater than 1. Oh, greater than 1. Should be at least a frame. Is that true? Definitely 5, 6. Yeah, I think that's what I want to do. It's kind of weird because it's kind of a latent test. It's like, you know what I can do here? Let's give it, let's say 10 milliseconds. Sorry. Just to give it a little time so that it actually takes, to make sure that we get at least a couple frames in. So there's always more than one frame. Yeah. I think even in a release build, that should be fine. Then we should have no, this equals. Does that work? Is that how it works? Yeah. Oh. Forget it's partial. Expected actual. Always forget the order too. Expected that many. Actual should be that many. I mean, I don't think there's anything more to test than this. And I wish I had some more. One thing I can do just to. I don't want to pervert the test by having timing related things, but I do want to make sure it takes a certain amount of time. All these, I mean, some of these textures are kind of bigger, so it'll take a little time. Most of these are slow. Anyways, these two tests are a million times better than no tests. Okay. Okay, so I'm happy with this. We at least got some test in here that should work. The one thing I want to do, though, is disable it for GL. How do we do that? Yeah, revert the tests. Yeah, okay, that's what I have to do. I mean, I think it does work in GL, but I'm not totally sure, and I just don't want to spend the time doing it. Really, at this point, I don't think we're going to spend a lot more time trying to get GL to be better. It's stable, mature, should be fine. So I should disable those tests on GL platforms. So for shits and giggles, same test should be in here, but you're going to run into the same problem here. I can't copy the DLL. Yep, same old garbage. First, let me turn off this verbose logging. That didn't help me at all, which is very annoying. Okay. What's that we did here? Went back to this. I'm just going to do this and then just fix it. I think that was called, what was it called before? Windows DX. Oh, yeah. Oh, interesting. So it's called Windows DX even for that reason. Let's see. Let me double check. Computer time was direct Windows. Okay. It worked. So that's good. All right, some new tests here. I mean, in theory, we should really have these tests for a bunch of different resource types. And really, this test could probably be changed to be like just graphics threading tests where we allocate lots of different types of resources, you know. Working on the back end is the good stuff. I don't know about that. I kind of got the impression it was the opposite, but who knows? Who knows? I don't know what makes things excited. People excited. All right, so back to this. Hi, you buddy. So with this, so let's go look at a couple things here. So if I go back to the regular Windows DX11 build, I'm running the same thing, debug here. So kind of an apples to apples test. One of these days that issue will go away. So same thing here. You can see our times. Just wanted to verify that. Now look at when I load this, how much faster this is. Like that was like a second and a half, maybe 2 seconds. See the frame rate here, the draw time is faster, right? Like sort of the same-ish kind of place. You can see it's like 3 milliseconds, 3.5 milliseconds, whereas Vulkan is like 5.5 milliseconds, 6 milliseconds. So DS11 is still faster here, and it's mostly because of just, you know, how we're having to keep track of state. You know, it's obviously not as optimized as what DX11 does to internally keep track of state. Yes, that's double debugging. Watching me debug while you're debugging is double debugging. We can also see that that light is stable. It doesn't explode. That said, even though our draw time is longer, notice that our frame time, our FPS is about the same. It's just taking a little bit more CPU time, and the frame rate is about the same, 70 to 60 milliseconds, because the GPU work is basically the same. So the GPU is taking the same amount of time. It's drawing the same amount of pixels and everything, even though it looks like sometimes things are a little bugged. It's basically taking the same amount of time to draw things. But the CPU is taking a little bit more time, which I'd like to fix. Even though I was told a long time ago by Microsoft engineers that they felt like these new APIs, DX12 and Vulkan, are not going to really make a single-threaded game faster. In fact, they might make a single-threaded game slower. And this game at the moment is single-threaded as far as it doesn't do any loading in the background. It's not trying to calculate light clusters in the background or anything like that. So everything's happening in the main thread. If I start moving some of this stuff off to the, off to a worker thread, it could improve the performance. But right now, I just want to see how fast I can make this. Anyways, so here's DX11. Let's go take a look at the X12 real quick. Nope, not you. Where is it? And run that. I haven't run this in a little bit. Let's see if I've broken anything. It loves to start in some weird position. So it's our startup time, about as long as Vulkan. The performance is much worse. That is noticeably worse. So we definitely have some issues there. Even when they sync off, draw time is taking forever. So this is the same problem. That, you know, it's probably similar issues. You know, that the texture upload is blocking for no reason. In fact, I can check that. So I put a hack in here for, where is it? Light cluster renderer. Clusters. So I put in a thing in here to disable the light cluster upload, disable updates. So if I come in here, so disable updates true. Hey, our draw time's now down to 5-6 milliseconds. So that was the first thing, right? Like, it's the rendering's still taking forever. The frame time there's taking forever, but I think that's the texture upload, I bet, is causing that. Or no, it can't be the texture upload. Something else is causing that. So that's interesting. But draw time is to a reasonable time once I stop doing the texture upload in the main thread. So the texture upload is definitely causing it to block. So there's something happening there. So let's take a look at that real quick. We can put it back, I guess. Let's just go straight to the what is it called? Creates an immediate resource, begins a new command list. Who knows what that's doing under there. Bet you what the problem is here is it's probably blocking for the command list to be completed. This is something I ran into the other one, that you can't just wait for it. Which you want to block if you're like, okay, I'm going to set data, then I'm going to call get data immediately. So if you're doing that, yes, you have to wait till it gets done. But if you're not doing that, then that's a waste of time, and you're just causing it to just, there's a resource barrier for the transition, right? And then close list goes to the pool, queue execute command list. So this executes the command list, blocking true. Well, that'll freaking do it. That's the issue, is that causes the whole thing to go synchronous. So that's one of the issues, is that how often is this happening, from where? Happening from set data? Is it happening from anywhere else? Nope, just from set data from light clusters. So that's one thing. I think the reason it's doing that blocking is, I mean, one, it's just lazy. The code was written that way to begin with. It shouldn't be blocking, but what it should be doing is if somebody calls get data on it, it has to say, is that texture copy done yet, before it actually does the real get data. So that's the first thing, is that get data has to wait until any pending set data is done. So that's the first thing that has to be fixed here. It's get data blocking. It's also using a command list to copy, but it's blocking on it. And really, in the get data case, it has to. because we don't know here in this case. Yeah, it just has to because it needs the data immediately. So that's always going to block in one way or another, even if you have kind of like, well, it's on the CPU. It's really just a texture, so it shouldn't have changed. So I don't need to wait for the GPU to finish or anything. Like, you still need to block for it. So this one you'd have to block. But I think how this is working is it might be blocking the main thread. I don't think anybody calls it though, at least not in here. Yeah, and all the set data, get data are not written to be like, hey, call me back when it's done. They're written to work immediately. Well, set data in theory, you could internally makes a copy and then starts submitting that to the GPU. So it could be latent like that, but when you call get, it has to block and wait, and that's fine. No one expects that get data of a texture on the GPU is going to be a fast operation. So but setting data should be. So this should stop blocking. But if we do that, it causes, it means that I have to fix get data. That said, with this disabled, let's just test this real quick. I don't think anything will break if I do this. This is our set data, right? I'm going to say don't block. I think there's actually two set datas. I have neither of these block. Fat fingered it. I'm going to have neither of these wait. I think the same mistake in here now. I think it'll still run, but it's not right. I just want to verify that gets rid of that bottleneck on the CPU side. Oh, well, there you go. Definitely didn't like that. Wait, what's the problem here? I don't understand what happened here. That's interesting. What has gone wrong here? What is all this garbage? Microsoft. I didn't change anything here. I bet you this, yeah, I bet you what happened here was it went to the pool, grabbed a dozen block, and somebody reused that command buffer later and broke something. Yeah. So yeah, the way that it's doing that, it can't really I mean, it needs to wait until the command buffer is done, not until it blocks on the GPU, at least. Begin pops off the front, and end does what? Pushes to the back, I guess. I think so. Let's see. It's a queue. I always forget the order of the queue, but I think it's first in, first out. So yeah, it's reusing the command buffer right after that, and that's what causes that to fail. What's the right way to handle this then? Executes the command list. The command list is still technically being used. We just need to know that the fence is completed. So I just need a block on this fence value. And that we do that somewhere here. Oh no, but we don't want to do that. Wait, is that the one it's doing there? Yeah, I mean, it's calling that, but that's a... How does that work again? Fences wait on the CPU, and fences are on the CPU, and semaphores are on the GPU. I guess this is waiting until, because that fence value comes from command list. Right. Yeah, it just can't reuse this pool until after that. This is going to take a while to fix right, because this stuff is not really written for that kind of performance, unfortunately. What's the right way? I'm trying to think if there's a straightforward, simple way to address this, but there just really isn't. This is definitely causing it to be slow. I mean, that mutex probably doesn't help either. That said, there's still more performance issues there. We'll get back to this one in a moment. Yeah, we'll get back to that one. Let's leave this going here for a second. At least we know where this issue is at. I want to see what this other one is. No, gotta stop. Because there's two different issues. These problems are affecting multiple games, so I have to get this resolved. So really bad frame rate. Draw time's horrible, but we know that if we get rid of those texture uploads, the draw time is no longer horrible. I mean, I guess it is still kind of bad, but it's reasonable with a couple long frames in between there. But that's not too far off Vulkan. But we're still, our overall frame time is really slow, so the present is slow. Oh, you know what? I think I know what this is. Duh. Yeah, I think I know what this is. Yeah. Oh, wait, is that off? Just be sure. Or is it in here too? Yeah. So doing layers off. That's interesting. I wonder why we have it doing that. Not feature level 12. Usually you give it like fallbacks, but interesting. Well, maybe this isn't the issue. Because I was thinking that maybe the debug path was still enabled, causing it to do validation and stuff, which kind of like, that was another thing in the Vulkan layers. It was doing validation, and that was slowing everything down for no reason. But it's not, doesn't look like to be that unless it's somewhere else in here. I don't think this has any debug assertions or extra work it's doing in debug. Just want to be sure that we don't have some debug. I don't think that does any. You know what? Just for shits and giggles, let's just run it in a release build real quick. Just to be certain. If the release build performance is still poor, then we know it's not a debug thing. Doesn't mean there couldn't be some validation or something like that on that shouldn't be, but. All right, let's run this real quick. Load time better. Yeah, still very poor. There's some weird stuff happening in the lighting in the background too. Desync off. Yeah, draw time's bad. So there's still something really wacky going on. Let's see if we can nail down what. I mean, that rendering's pretty demanding. And we did notice that there's some performance issues on one game that we're testing. We can't quite hit 60 on Xbox, which is poor because we hit 60 on Switch with the same game. So that tells you something's up, right? Well, let's start with a simple thing. Let's just run the profiler real quick and see what we get. Nope, don't want to do that. What? No, we'll do it that way, I guess. That's fine. And turn off VSync just for shits and giggles. I won't move it. CPU usage. I don't think that's worth anything. Let's just see if this happens to spot what's going on here. It may or may not. Seems like a good amount of data. I've had the problem before where I had to redo it and debug because it doesn't give me enough information. We'll see. I already don't like any of that. That's probably sleep time, but 13% and whatever that is, that's probably not great. Chunk of time there. Said common draw. I mean, that should be true. I forget how this works. Where is it? There's a drop down here somewhere I'm missing. Oh, it's in here. The details. So here, apply state, apply current pipeline state. Seems like, oh, God damn it. You just go to, no, call tree. That's the one I can actually understand. Tick, expand hot path. I mean, that's expected. Okay, so here we're in the native code. Apply state is a big chunk of time. This actually loads module symbols. See if it'll load symbols. Sometimes those are helpful. Thanks for hiding the path I was looking at. That really helps. All right. Set graphics root constant buffer. I mean, that's get GPU virtual address. That makes sense. Apply current pipeline state. No clue what that is. So a lot less. Just funny how it sheds time all the way down, and then it's like, oh, now it's nothing. If I pass apply, it doesn't do very much. Yeah, this is the same sort of problem I ran into with. This is the same sort of problem that I ran into with Vulkan, is that looking at the call stack didn't give me any good information that could really help me pinpoint, well, why is it slow? Why is this so much slower than something else? When I went to just a flat function list to self-time, that's interesting. I mean, that's a single call, right? Is it creating a bunch of resources every frame? That wouldn't be good. I'll look at that real quick here in a moment. But overall, like, there's nothing. It's an individual small function that's taking a bunch of time. That's the first MG runtime thing. Yeah, it's like looking at this is deceiving. It's like you can't really see why.
Frankly, my dear, I don't give a damn.
Okay. Curious about the resource creation. So yeah, this didn't give us too much good information here. Didn't give us much information at all. I think I can lock on resource creation in here somewhere. Where can I do that? What's going to be an easier way to do this? Just go to the texture code. That's where I want to be. Just want to see if this is getting called a bunch while it's... Oh, I should run a debug build. Otherwise, it may or may not hit that, and that's a big pain in the ass. Ugh. Still don't fully trust that there's not some debug layer enabled. Okay, super bad performance. Okay, so set data is causing a resource creation. Let's take that off the table. Real quick. I hate the fact that I have to write the word true there and not just put a 1 in. Okay, so no resource creation. Because before when I measured it, I had that stuff on, so that's why that showed up. I should have probably measured it with that off, huh? That probably would have given me more information. I make the window a lot smaller. So you can see if I made the window a lot smaller, the render target is smaller, it should be rendering less pixels, there should be some performance improvement than in frame time. And there isn't, which it isn't fill rate bound. There's something else binding it. Since the lighting is disabled, we're getting some artifacts. No resource creation. Make sure there isn't something else in here that's... God, my mouse wheel is so freaking screwed. Okay. So yeah, it looks like it's allocating anything. So it's not that, it's just strictly inefficiency of something. I know there's some things that are inefficient. I mean, one thing that I've rewritten locally is how constant buffers work. Basically, they're working like push buffers do on Vulkan. Wait. Create. There we go. Wait, why is that? There it is. Shouldn't be creating any right now. But if it's a push buffer, if it's a constant buffer, it treats it as a push buffer, meaning it just has a single, says CPU memory, it mem copies the data into it, marks it as dirty, then down here, and apply state. We have one giant actual, not one giant, but like in here. So we have basically these, a ring buffer concept here where it basically keeps track of a big chunk of GPU address, a big chunk of vertex data or vertex or GPU memory is used for uniform data. It basically just fills it. Once it gets to the end of it, it allocates a new one if it needs to, expanding it, and just reuses it over and over and over again instead of a bunch of little allocations what the GPU is not good at. Is this branch available in Second Games? I just want to see if I can get a head start on rebasing my branch. The test fixes this. No, and I haven't pushed that yet. I could, but my worry is that it's not ready, you know, and obviously something here is pretty broken. I really need to figure out what this is before I can say like, oh, now that I figured this out, then I just don't want to push it and say, hey, rebase based on this, and then everything changes. I really just need to see what the problem here is first before I actually merge it. Because if I don't know what the problem is, that's kind of a concern. So where is it? Data. There. This is not actually allocating anything. So yeah, when it goes through the uniform buffers, it gets the ring buffer, and then if a uniform is dirty, it allocates. It doesn't allocate. Actually, I should call that something different. It says, "Hey, I need some data here from the ring buffer." It returns back a chunk. You know, it copies the data into the actual GPU data and then sets it on the constant buffer or on the graphics device or on the state for the graphics device. The what do you call it? Command list. Yeah. I mean, I do wonder whether this. I mean, I rewrote this because the previous implementation was really bad. This was better, but it didn't solve the problem, which tells me that there's still something else going wrong here that I'm not seeing. I mean, there is some work that I'm doing now on. I wonder if it has something to do with that. There was something. Let's go look at the differences I have here. So ring buffer code. There's some new data that comes in. We know from each shader what the max texture slot, the max sampler slot are on that texture or on that shader. In particular, it's so that we don't have to burn 16 slots every vertex and pixel shader, for sampler state, which is kind of a limited space resource on the in the what is it called, the root descriptor. Some more debug stuff. Yeah, that was something I fixed, that it wasn't handling the sync, the vsync properly before. So that's a good fix. It's simple. What is this? Yeah, this is also the fix that matches the other word. Like for begin frame was screwed up. So begin frame does nothing. Prepare next frame is what does the work. I mean, it still does some things. This might need to move out of here. We'll see. And this has to be here for just in case. So only if, for whatever reason, the frame hasn't started. Which that shouldn't be happening on a regular basis, but we'll check to make sure there's not something dumb happening here. No, okay. Want to be sure. Oh, wrong thing. Yeah, so same design. At the end of the frame, it prepares the next frame. Oh, come on, thing. Yeah, that was just if the buffer changed when we set constant buffers, hey, mark it as dirty. I think this is something that I have to deal with in a better way. I don't think that this. It's just something I have to deal with in a better way than I am at the moment. This was a simple thing. If the slot isn't, you're not actually changing the sampler, don't set it so that it doesn't mark it as dirty and cause it to upload a new set of samplers to the descriptor state. Or not the descriptor, to the root descriptor, yeah. Hang on, sorry. What's this? Keeping track of the current shader, yep. Nothing here is different than it did before. Really? Just slightly different. Yeah, I don't think anything here was actually the cause of this. If anything, this performance problem has been here this entire time. Let me go look real quick, though, at one other thing. Shit, just tested here. I hate Visual Studio's built-in diff tool. Non-compare is so much better.
Frankly, my dear, I don't give a damn.
I forget why that was for there. Yeah, whatever. Machine's been really slow lately. Yeah. Yeah, that's a default clear color thing. Yep, that's part of the deal that I changed there. Shits and giggles. Let's just verify that it's not doing that. I mean, I don't think it is. I was going to say. That'd be wild if it was like using the warp adapter. Yes, that's not anything there. Interesting. So there's a difference, but there isn't. Yeah, not much different. So there's still something latent in here that shouldn't be. There's just something here at the implementation level that is causing sync. I'm going to have to see if I can. First frame does that. Didn't think so. Let's try something different here. I tried running this the other day. Let's see, where is it? This guy? Nope. Let me put it over here, just in case. I think this is the right tool. Yep. Picks. Had a launch process before. It looks like it was launching process. Let's see if Pix can help us. Pix, take me away. Yeah. Pix should be capturing data now. Let's see if it can tell us something. Stop capture. I think I can safely kill this now. Cordialization is low. I haven't used this version of Pix in forever. Maybe look at each individual one by itself. It's annoying. So all our CPU usage is low. It's percentage. So no CPU is using a lot of time. Man. This is so stupid. What's this? Okay, that's what I thought. This is some GPU is not like a recent GPU. It's an older GPU. These are different stages of the hardware. Oh, what's this? Graphics Engine 1. That's up there at 90% usage. Finally, something informational. Don't really run any compute. I mean, this doesn't really tell me much, really. This view is really not telling me too much. Yeah, I don't think this is helping me too much here. It's not giving me any targeted information. It's like all the information is very generic. It's not telling me shit. I hate it when I can't get good data out of this thing. Yeah, it's not giving me shit. Okay, let's try this again. This is GPU capture. Let's see where we're at on things. Let's see if there's not anything dumb happening in the state. Okay. Oh, come on. Just a guess that there's a divider right there. It's not here. It's not down here. It's right there. All right. So I don't like all this. I mean, this is probably those. That's probably the setting of the. That's probably these signals and barriers are probably all the in this text copy region. This one at the beginning. Copy does that. And then I think. Command list object 4. Work list object 4. So this is all the set data, I'm pretty sure. Then this wait. Command key wait. I don't like that. It's waiting for a fence. Not telling me who signaled that, but whatever. Resource barrier, draw instanced. Controller instance draws. I have to dig into this further. It's a lot of instance draws. Because it is drawing a lot of stuff. That's part of the problem. And not in a very good way either. Resource barrier, then it clears. More instance draws. That's the main frame, I think. A couple more resource barriers. This is probably the final scene with like the HUD and stuff like that. Two fences here. Object 1, Object 3, and Object 360. Huh. Remember what those signals here at the end. That must be our cleanup at the end of the frame. 100%. So, let's collect timing data real quick. Timing data is in nanoseconds. So that's 42 milliseconds there. Wait, is that right? No, that can't be right. I think it's actually a million. Yeah, it's a million of that. So that's not even close to that. That's a fraction of a nanosecond there, or a millisecond. Let's take a look at what's the slowest. So that's 5 milliseconds there, 5 milliseconds, 5 milliseconds. That's not good. I mean, wait, what? What the heck is that? Index count per instance? That's interesting. Index count per instance is that? Does that make any sense? We have a mesh with 4 million indexes? That sounds suspect. That sounds suspect to me. Let's go take a peek. That doesn't even sound... I mean, I know we have some meshes that are big, but I don't think we have any mesh that big. And that would definitely be... It's drawing a lot of meshes at that size. That's kind of crazy. Wouldn't surprise me if it's made... I mean, would that cause a crash? Like if it's calculating the index wrong, I think it would blow up. I wouldn't think that it would just function. Well, there it is. First fucking try. A million triangles? Really? Does that sound right? That's really suspect. I mean, I'll double check the Vulkan code. The very first thing it draws ends up being that. I mean, I guess it's possible. I know we have some big meshes in there, but that big? It seems suspicious. I guess the index count does make sense. But is that right? Index count per index. Instance count. Start index location. And that looks possible there. Current state generic read. Upload. Heap type upload. I don't know if that's good. I think that's actually kind of bad. That could be causing some of our problems, I think. Yeah, that's not good. I think this heap being dynamic here is part of our problem. Yeah, that's probably not good. I mean, for dynamic buffers, that makes sense, but that's too big for a dynamic heap. I don't know why we turned this off. Let's go take a look real quick. This is possibly the reason why this is inherently slow. But I mean, this is only going to affect something like this. I think the reason that this happened was that I think with static, you can't. It puts it into a state of you have to copy to it once. But I mean, it's going to, fuck that. How did the buffer heap type get set? It doesn't. Let's see what breaks here. I'm pretty sure the reason I can't do this is because somebody needs to be able to copy into it first. We'll see. I think all the constant buffers are going through there. Actually, this is going to break because it needs to be only for static things and not dynamic. So I can't do that. That's the thing, is that I guess that's what the issue is here. I'm just saying, hey, this is a vertex buffer. It can't make it. Yeah, it doesn't know that this is going to be written to one time. I think that I can't say for sure, though, that that's actually what's causing the problem. Let's just see what it freaking does. Failed to allocate. Failed allocated. Let's see what we set data on it. It's probably gonna, let's see, it's creating a vertex buffer for what? For something. Okay, let's let it keep doing that for right now. Don't like that, whatever that's about. Yep, that's what I thought. Huh. Okay, well, that sucks. The problem is I don't know for sure if this is the cause or not. I mean, I think there is a performance implication to one versus the other, but I don't know if it's that great of a difference, but it could be. And knowing that, I guess that's part of the problem, is that at this API level, we don't pass any information here saying like, oh, by the way, I want a dynamic vertex buffer. Like our high-level API does not say, oh, I need a vertex buffer that's dynamic. I mean, here it's just creating a static vertex buffer. So even though that's another complication, just because this is a vertex buffer and you're not saying that this is, I guess there is this write-only usage, but it doesn't read, but it can still write more, right? So there's no concept in here in XNA that you might not eventually write to a vertex buffer that isn't dynamic multiple times. So they all kind of have to handle being dynamic. But it could be that you could say that vertex buffer should handle it less gracefully, whereas dynamic vertex buffer should be prepared for it to be dynamic. You know, and currently I don't think we're doing any differentiation here. Like when we create a vertex buffer, I don't think we're even creating one anywhere. Like it's derived from the base vertex buffer. It does not pass, I guess it passes a true into here. That is dynamic. And that's stored. But platform construct, which does the actual creation here, does not use the dynamic vertex buffer for anything. I mean, it just uses the dynamic to decide whether discarding is going to happen or not. Which at that point it could discard potentially. It's funny, I think the first time that this is called, it will discard the buffer even though it's never been used before. It's another dumb thing it's doing, discarding a buffer on first usage. Is there a quick way to check that you even have a model that big? I mean, I think we do. It's possible. I don't think that's wrong. I mean, one quick way would be to just do this. Switch to the desktop VK build. Oh, damn it. Gotta stop. And then do the same thing, Vulkan. Where is it? So that's all I was doing was I came in here and said, hey, let me set a breakpoint draw index and see what the biggest thing is. This comes up to 4 million as well, index count. Then, yeah, if it doesn't, then okay, something else is going wrong. I can't think of what could be going wrong here that's specific to Vulkan versus DX12. I mean, that stuff is the same for both. The model loading is all the same, and the size of data in a vertex buffer is all the same. But maybe I'm wrong. Maybe it's doing something stupid. I mean, that's significantly different. I mean, that's definitely lower than the other, but I can't say. I mean, that is lower, much lower. Is anything that big? Maybe there is something going wrong with that. Let's set a conditional breakpoint real quick. Okay, there's a 2 million. I mean, but still, that's not what we were seeing with the other. I mean, that's still a lot of indices. Is that how big we have on the other one? Is that? I'm just checking real quick to see if that's one frame. No, there's a 4 million one. So they are in here. It's just significantly faster for it to render this. And again, millions of triangles is not that slow, really. It just seems shocking that they're there. And obviously, it runs fine here. The GPU can handle millions of triangles. It's not efficient. And I know what it is. It's this room is, you know, kind of intense. I mean, that's the collision data, not the... Pretty sure that's collision data. Can I have a wireframe mode? I had a wireframe. I think that's just the collision data, not the actual visual mesh data. Anyways. But I know that this stuff is... Some of this geometry is kind of out of hand. still. There we go. But this thing hands like a champ, the other one doesn't, right? So yeah, there's still problems here. Not quite as far as I wanted to get to for today. I mean, we got some more unit tests. I can probably push some of the Vulkan fixes because those are good. So I'll spend a little time and get that pushed up because that is a improvement to things. It's clearly working better, but I need to spend some more time on DX12. There's no choice to that. Yeah, I just have to spend some more time on DX12. That's the only thing I can really do at this point. So yeah, oh gosh, it just seems like another 2 hours passed and I didn't get anywhere near as far as I wanted to. Learned some stuff, fixed at least a thing, but not quite where we wanted to be. I still need to figure out what's happening there with DX12. Like there's something inherently broken in there. I'm going to have to like go in detail. I might need to potentially disable things that are different, you know, like disable some post effects, disable some like the shadow rendering and a couple things like that, and see if I can identify a certain section of the code that is particularly slow compared to everything else. There's got to be something that is a synchronization point on the GPU. Like I do wonder if looking closer at our actual our capture might actually show me a little bit more data that I'm not noticing normally. There's got to be a synchronization point here of some sort that's causing it to do this. That's causing it to really slow down. Because I can imagine this should be able to keep up. It's the same GPU. It should be able to keep up. There shouldn't be a difference here. So it's got to be like the memory that we're allocating for textures and or vertex index buffers that is suboptimal and it causes it to be slower. Or something like the state that we're pushing for constant buffers, or for changing, you know, actually updating the descriptors set, the root descriptors, like that might be inefficient. It's got to be something like that. Because it doesn't make sense to me otherwise. So yeah, I'm going to have to look closer at the resources, I think. Because I sort of feel like maybe the resources are what, you know, what potentially is the issue here is the resources. So I'm going to have to dig deeper in this capture that I have and see if something in that capture can point me at an inefficient resource that is causing it, or if there's something in the capture that can tell me like, oh, here's or here's some synchronization that you're doing that is slowing the thing down for no reason. Which at this point could be on the GPU side or the CPU side, I guess. It could be either. Yeah, I mean, it could be either at this point. So yeah, not satisfying. I was hoping I could get this resolved today. This is starting to seem like a deeper issue that I'm going to have to really spend some more time on. Significantly more time. All right. Well, it is what it is. Nothing I can do about that. Oh, weird. The reflection on my face as I move a screen across my monitor. Casts a bounce light to my face. Fun. All right. So what did we learn? The same code base, same resources, same assets, two different graphics API implementations, vastly different performance results, which that really sucks. So I'm just gonna have to sit here and dig deeper into this. So I'll probably get into this over the weekend. I'll probably sit down and look at this closer because there's something I'm missing. Yes, I will let you know what it is, Slappy. I definitely, once I figure this out, I will make sure the next stream that I update you guys on what it is. And for sure, when I push a PR for this, eventually, I will make sure to say this is what was causing that, because it is kind of disturbing that it can be that different, you know, but it's got to be a subtle, sometimes it's a subtle thing. It's a little synchronization. It's a little, you know, oh, I allocated the memory slightly differently. One flag somewhere is all it takes, especially when you're dealing with resources that are this big. So yeah, I think that's what it's going to be. All right. Well, I appreciate you guys being on the stream. Thanks as always. You know, follow us on Twitch and YouTube. We're always trying to expand our user base there. I don't know where we're at on Twitch at the moment. Let's see. We're at, I know we were trying to hit some sort of milestone. But I don't remember where we were at on our milestone. We need 2 more subs to go, is what it says. I don't know. Hey, 3 of you guys on there on Twitch. That's great. Thanks for following us there. And as always, you know, MonoGame's always looking for donations. You know, and donations is not like just monetarily, but also just your time, your effort, feedback. You know, those are the things that we need more than anything else. Testing, just firing up MonoGame, test some stuff, play your game on it, try some different things with it. We're always looking for people to try things out, especially the newer stuff. We have a preview out for 385, which we thought was the final preview, but obviously there might be one more. We'll see. All right. Thanks, everybody. Bye.